Hello friends and welcome at my channel. Today I would like to show you guys how the graph of a polynomial function f of x, which is x minus 1 squared times x plus 2 looks like. So once again, how do we start? We do start with the domain, and x is every rational number, every real number, so everything is fine. Number two is we are talking about symmetry. So what kind of symmetry could we have here? Well, it's maybe not so obvious here. Maybe it's better for us to multiply it out first and then see what's happening. So we'll do it. We're just having x squared minus 2x plus 1, the binomial formula, times x plus 2. What's happening next? We're totally multiplying it out. Okay, so we're having x cubed minus 2x squared plus x plus 2x squared minus 4x plus 2. This is gone and this is gone. We got x cubed minus 3x plus 2, and that's it. So do we have just odd powers? No, we don't, because of the 2 times x to the power of 0. So this function isn't strictly symmetric considering the origin, but that would be symmetric considering the point 0, 2. Let's keep it in mind, okay? So since almost all of the powers are odd, we having here just xo. So considering the point 0, 2, we're gonna have symmetry. It's not so obvious to see, and well, it's not that helpful maybe in many cases, but let's write it down. So pointwise symmetry considering the point A with coordinates 0, 2. Okay, what about behavior towards plus or minus infinity? Well, we'd rather consider this form of f of x. So as you can see, the strongest power in this case is 3. If x is running towards infinity, x cubed is also running towards plus infinity. So basically, we're going to have infinity here. And if x is running towards minus infinity, we are going to have minus infinity here as well, because if we put very big negative numbers, the result is a very big negative number as well. So we're coming from downstairs, doing whatever, and coming up. Okay, number 4 are the points of intersection. Well, in this case, we rather use the first form, so x minus 1 squared times x plus 2. Just have to make sure I got it right. Yeah, that's all right. So we are having a double 0 point here at 1 and a single 0 point at minus 2. Okay, so 0.1 is doubled. You remember what it means? That means that the first derivative, I showed it in the last video, I think, that the first derivative is also 0 at 1. We will see that. So let's look at this, number 5. Okay, we can also figure out the point of intersection with the y-axis. Just put 0 for x. That would be 1, and that would be 2. 1 times 2 is 2, so 0, 2. What a surprise. We knew it, all right? Because of the last form after we multiplied out. Okay, once again, here for extreme values, we'd rather consider x cubed. What was that? Minus 3 x plus 2. Minus 3x plus 2. So what is the first derivative? This is 3x squared minus 3. And as you can see, if we put it equal to 0, we can divide it by 3, we're going to get x squared equals to 1. So x is really plus minus 1, which is, once again, so at least plus 1 is a 0 point. here as well. So we need the second derivative, f second prime of x, which is just 6x. And as you can see, f second prime at 1 is 6 positive means min. F second prime at -1 is -6 negative, which means max. So what is the coordinate of min? This is 1. And what is the y value? Well, if we put 1 here, we're going to get obviously 0. And what about max? This is -1. So if you put -1, it's going to be -1 and -1 plus -2 squared 4. 4 times 1 is 4. So we got min at 1, 0, and a max at -1 for number 6. Points of inflection. For these purposes, we need the second derivative. The second derivative is 0 at 0, and the third derivative is just 6, so none, 0, anywhere, just 6, none, 0. So we're done. That means the point of inflection is at 0. It's 0, 2. Do I have enough information? I think so. So we started here. It was 1, a double 0 point and -2. 1 and -2. 0, 2 is an important point as well, which is a point of inflection here. And extreme values were, we also had one at -1, -1 and 4. -1 and 4. So what can we say about the graph? Well, look at this. We go from we start at -infinity. So we go like this, single 0 point to the max, to the point of inflection, to the min, and then we go up. And as you can see, if you really would cut it in half here, let me change the color, you would clearly see two equal pieces. The upper and the lower, they are really symmetric. So we would kind of have a symmetry considering this point. But normally at school, we're just talking about symmetry. At least in Germany, they do. It depends on the level of education, of course, but normally they would say that this is only pointwise symmetry considering the origin. Okay, guys, thanks for watching and see you in the next video. All the best. Bye-bye.